Assalamualaikum and hi. We are from Group 5. We want to present about lightweight concrete. Here our group member. First Amiruddin, second Shahmi, and third Anisha, and lastly Nurhayati.
Lightweight concrete is commonly used in the construction industries, where it is important to reduce the density of the concrete. The ordinary concrete is quite heavy and its density is about 2,300 kg per meter cube, whereas the lightweight concrete, the density is less than 1,840 kg per meter cube. The lightweight concrete is made by replacing some or all the normal weight aggregate with the lightweight aggregate. Often the cross fraction is replaced with the lightweight aggregate and the fines are normal rates, and this lightweight concrete not only result in reducing dead weight on the structure but also has a better insulation against heat, sound. However, the strength of the concrete is reduced. The most common use for lightweight concrete are with floor roof and bridge. Others include pavement system and masonry blocks and offshore oil structures. Lightweight concrete can be the lightweight aggregate concrete, foam concrete, or autoclave aerated concrete. Lightweight aggregate concrete, this type of concrete can be produced by using a porous lightweight aggregate of low apparent specific gravity. The example of lightweight aggregates are the Pullmans, slag and scoria. Foam concrete, this type of concrete is formed by introducing the large voids within the concrete. The foam concrete is highly workable and low density material which can incorporate up to 50% entrained air. Lightweight structural concrete. Lightweight concrete can also be used for structural applications with strength equivalent to the normal weight concrete. These are generally made with expanded shell, clay, slag, and fly ash. The minimum compressive strength will be 17.24 Newton per millimeter square.
Based on the previous study of the literature review, the purpose of this test is to identify the performance of aerated lightweight concrete in terms of density and compressive strength. The results are presented in Table 1 and illustrated in Figure 1. According to Ismail on his study of lightweight concrete behavior, compressive strength for aerated lightweight concrete are low for lower density mixture. The increment of voids throughout the sample caused by the form in the mixture will lower density. As a result, compressive strength will also decrease with the increment of those voids. The required compressive strength of lightweight concrete is 3.45 MPa at 28 days as a non-load bearing structure. The compressive strength obtained from this mixture carried out are higher than 3.45 MPa, and therefore it is acceptable to be produced as a non-load bearing structure. However, the compressive strength for the mixture with density of 2,050 kg/m3 is slightly low compared with the density of 2,040 kg/m3. This has resulted the compressive strength to be lower than the mixture with lower density. As shown in the Figure 2, lightweight concrete provides the same compressive strength as normal weight aggregate with approximately the same cement content. A typical performance chart of a given aggregate shows the various strength attainable with different amount of cement for both 7-day and 28-day tests. The method used to determine compressive strength. Compressive strength is the primary physical property of concrete. It is one of the fundamental properties used for quality control for lightweight concrete. Compressive strength may be defined as the measured maximum resistance of a concrete specimen to axial loading. There are three types of tests that can be used to determine compressive strength, such as cube, cylinder, or prism test. The concrete cube test is the most familiar test and is used as the standard method of measuring compressive strength. Types of lightweight concrete. There are three types of lightweight concrete. One is lightweight aggregate concrete, two is aerated concrete, and three is no fine concrete. For light aggregate concrete, they have two types, which is a natural lightweight concrete and also artificial lightweight concrete. Example for natural lightweight concrete is pumice, diatomite, scoria, volcanic cider, sawdust, and also rice husk. And for artificial cider, copperas, foam slag, floated clay, expanded shale, cidery fly ash, exfoliate vermiculites, expanded perlite, and also thermocol concrete. It is made by either a physical or a chemical process during which either air or gas is introduced into a slurry which generally contain no coarse material, and also other methods of aeration are by mixing in stabilized form or whipping air in with the aid of an air interning agent. For no-fine concrete is lightweight concrete made up of only coarse aggregate, cement, and water. There are no sand or fine aggregate is omitted from the normal concrete mixture. And also no fine concrete is an agglomeration of a coarse aggregate particles where each is surrounded by a coating of cement paste up to about 1.3 mm thick. Only single-sized coarse aggregate between 10 mm to 20 mm, either a dense aggregate or a lightweight aggregate such as century pulverized full ash is used. And it's also introduced into the UK in 1923 when 50 houses were built in Edinburgh, followed by 800 houses in Liverpool. Registered
Properties of lightweight concrete.
There are several properties of lightweight concrete, among of it such as low density, fire resistant, sound insulation, durability, thermal insulation, and quality control. Low density. The density of the concrete varies from 300 to 1840 kg per meter cube. The lightest grade suited for the insulation purpose, while the heavier grade with adequate strength suited for the structural application. The low density of the cellular concrete makes it suitable for precast floor and roofing unit, which are easy to handle and transport from the factory to the site. Fire resistant. Lightweight concrete has excellent fire resistant properties. Its low thermal conductivity makes it suitable for protecting another structure from the effect of fire. Sound insulation. Sound insulation in cellular concrete is normally not as good as in dense concrete. Durability. Erected concrete is only slightly alkaline due to its porosity and low alkalinity. It does not give rust protection to steel, which is provided by dense compared concrete. Thermal insulation. The insulation value of lightweight concrete is about 3 to 6 times that of brick and about 10 times of normal concrete. Quality control. Better quality control exercised in the construction of the structure with lightweight concrete product owing to the use of the factory-made unit.
For lightweight concrete advantage and disadvantage, first we see the advantages. The advantages of lightweight concrete is reduce the dead load of the building. Second, easy to handle, reducing the cost of transportation and manpower. Third, rapid and relatively simple construction. Next, improved workability, relatively low thermal conductivity, comparatively more durable but less resistant to abrasions, has application in a pre-stressed concrete, high-rise building, and also shell roof. good resistance to freezing and thawing actions when compared to conventional concrete. And lastly, help in disposal of industrial waste such as fly ash, clinker, and also slag. For the disadvantages, lightweight concrete is very sensitive with the water-cement ratio of the mixture. Second, it's difficult to place and finish due to porosity and availability of the aggregate. Third is, in some mix, the cement mortar may separate from the aggregate and float toward the surface. Fourth, mixing time is longer to ensure proper mixing. And lastly, lightweight concrete are porous and show hole resistant.
Application of lightweight concrete.
There are several applications of lightweight concrete. First, the structural lightweight concrete can use for the construction for residential and non-residential building in seismic area. Second, this concrete can also be for the construction of underground bunker. Third, structural lightweight concrete can be used in the pier and beam, slab and wall element in the steel and concrete frame building. Fourth, the lightweight concrete can be used for making a structure such as precast wall block and panel of the building. Next, lightweight concrete can use as heat insulation on roof. Lastly, lightweight concrete is also used for reinforcement.
Today we're on
concrete.
site at a large commercial project that's being constructed here in Midvale, Utah. On this project, the design calls for the use of structural lightweight concrete. You know, you might hear it said that structural lightweight concrete, it can't be or it just doesn't pump well. But like any other concrete pumping project, with the proper preparation, knowing a few key points, and everybody involved understanding their role, it can easily be pulled off.
Joe, in your opinion, what's the main difference between pumping lightweight concrete and normal weight concrete?
The difference between lightweight and regular weight concrete, normal concrete, is the key to success for lightweight is you have to have soak with water. Not so much chemicals, but you need the water to saturate the material so the pump isn't pressuring it through and absorbing the moisture in the material, and then we end up with a real dry slump at the end and it's wet at the beginning of the pump. So the key is water, saturation, that's it. The problem when you pump lightweight is this. A lot of people think when a pump can't pump concrete, the more pressure you're going to put to it to make it pump. Well, what we found out is the more pressure you put with lightweight, it's compacting, it's putting more pressure, head pressure on that concrete, and it's absorbing the moisture into the material. It makes it worse. You have to finesse it through. You can't ram it through. You just got to ask it through.
For conclusion, as a construction material, lightweight concrete is a good alternative for normal weight concrete. It has so many advantages over normal weight concrete. There are several new opportunities and challenges in the field of lightweight aggregates building industry. So, today lightweight concrete is widely used for many applications in construction industry such as road construction, mining, landfill, and tunnels.